we're going to hello everybody, we're going to review similarity. And so the first thing that we're going to talk about is how triangles become similar to one another. And one way to prove that triangles are similar to one another would be by the angle-angle similarity. And that basically says that if we have two angles in one triangle congruent to two angles in another triangle, then these two triangles are similar to one another, meaning that there is a proportion that the sides will be in ratio to one another, and so we'll end up being able to set up fractions and solve for the sides. So please pause the video right now and write down the information from here so that you have it in your notes. Our first example that we're going to talk about today is we are going to explain why these triangles are similar to one another, and then we'll write a similarity statement. And so we've done a lot about proofs and things like that, and so we should be able to look at this drawing and see a way to prove that these triangles are similar. Now, the cool thing about similarity is that we don't need as much information when we're proving similarity. And when we prove congruence, we needed three pieces, a couple sides, an angle, or a couple angles and a side, or a whole bunch of sides. But we needed three pieces of information. In this case, we really only need two. And so in this one, if we can prove the two angles congruent to each other, we would have enough, because angle B and angle D, as you can see, are marked as right angles. So we would just need one more pair of angles to prove congruent to each other. Well, by looking at the drawing and seeing two straight lines intersecting, I can say that these two angles will be congruent to one another. So I could say that angle ACB is congruent to angle ECD. Since those guys are congruent to each other, and we already know that angle B is congruent to angle D, by all right angles are congruent, we have enough to say that these are angle-angle similar. So with that being the case, the similarity statement that I would write, so to write a similarity statement, it's going to look something like this. It looks very similar to congruent statement, but we're leaving out the equal sign. So triangle ABC, and again, order is going to matter. And so ABC, so it's got to be EDC, and this is our similarity statement for this pair of triangles. So we proved that they were similar, and then we wrote a similarity statement. The next thing we have here is there's two more ways to prove similar, and basically, like side-side-side congruence that we dealt with in the previous section, side-side-side similarity works the same. The only difference is that instead of them being congruent, the sides being congruent, the sides are proportional to one another. And so that would mean that AB is to ED as AC is to DF, and what is it we got left? BC and EF. And so you'll notice the top triangle is all across the top there, the bottom triangle is all across the bottom, and I matched up the corresponding sides that they were. And so if they all reduce to the same fraction, then we would have triangle similarity, these triangles being similar by side-side similarity. And again, here's a similarity statement to represent what's going on. In the other one, we have side-angle side, which is very similar to side-angle side congruence. The only difference is the sides are in proportion and the angles are congruent. So angle B and E are congruent here. So with that being said, then we would have to prove that AB and ED fraction is equal to BC and EF. And if those fractions are equal to one another, then we have side-angle side similarity, because we know these angles are congruent to one another. So if you would please pause the video here and write down the information that you need, and then we can move along. So here is an example, and we want to verify that PQS and QRS are similar. All right, so we're looking at this, and I'm trying to look at the information that is given to me. I don't really know any information about angles in these triangles, so I'm not going to be able to use. So I really have three options: angle-angle similarity, side-side similarity, and side-angle side similarity. Well, in this case, I don't have any angles that I know that are congruent, so I can't use angle-angle, and I'm not going to use side-angle side similarity. So I'm going to set up proportions and make sure I get these guys in the right order. So the order up here is going to help me get these guys in the right order. So we're going to check and see if these fractions, when reduced, match up. So you'll notice that PQ are, so I'm going to write this as PQ and QR that fraction must be equal to the fraction of QS and RS. So you can see that I use the first two letters, the last two letters, and for each of them. And then the other one that has to also, for side, 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 is the first and last letter, so PS and QS. All of these fractions must be equal to each other for us to be able to use side, side, side similarity. So let's check it out. Let's see if that's the case. So let's fill in some numbers here. PQ is 12. QR is QR right here, if I get the right side, is 8. All right, so let's see if the side of QS, which is also 12, is similar to RS. RS is 8 here. So far these guys are equal, that's great. And then the last one we got to look at is PS here. 18 is to, well, QS, which is 12. All right, so I put everybody in there, and I'm going to kind of have to reduce these because I'm not exactly sure how 18 and 12 work out in this. I can see these guys are congruent already, so or equal to each other. So let's just reduce them. Let's divide by 4 across the board on everybody. I'm going to divide all the fractions by 4, and so by doing that, this guy divided by 4 gives me 3 over 2. This one gives me 3 over 2 for those two. And actually, I'm not going to divide by 4 on this one because I think I got a bigger number, like 6, that both of these guys can be divided into. So these two over here got divided by 4. And these guys, you don't have to divide by the same numbers. And when I divide by 6, it looks like I get 3 over 2. So these guys are similar to one another because all the fractions reduce to the same proportion, 3 over 2. And remember, this is their similarity ratio. That's how they relate to one another. We have this one other triangle down here, and we want to verify that these guys are similar. And so these guys were similar by side, 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 similar up there. So moving on to this one, we have that BDA and CDE are similar. We want to verify that they're similar. Now you'll notice that I know nothing about the side AB or the side EC. So going back to my choices, these are my choices for verifying things are similar. Well, in this case, I only know one angle in this triangle down here, and that angle is the same angle in the bigger triangle as well. Hopefully you can see that. If you want, you can unwrap it and draw the little triangle over here and call it ECD with a side of 3 and 4. But it's hard to see the reflexive angle when I move it over there. But this angle and that angle are congruent to one another. So we have an angle in them, so side, side, side isn't going to work. So it's one of these two. I'm looking at this, and I can't figure out if angle E and A are the same, and C or B are the same. So I can't do two angles. So I'm going to see if my sides are in proportion to one another. So if this side, that ED and DA are in proportion to one another, as well as DC and DB are in proportion to one another, then we would have side angle side similarity. So let's test it out. Well, if I go ED over, DA, like I just said, and DC over DB, well, if those guys reduce out then to the same fraction, then we have side angle side similarity. Well, let's look at this a little bit. We got to be careful. ED I can see is 3, but DA isn't 15. If you put 3 over 15, there's a chance that it's going to mess up. So we've got to add these two numbers together and get 3 over 18. Well, let's see if that's equal to the small side DC is 4 and DB is 24 when I add them together. So let's reduce these two fractions and see if I can get them in proportion. Since I already have an angle, if these guys are in proportion, then these two triangles are similar. So I'm going to divide this guy by 3. And you don't have to divide, you have to divide the top and bottom by the same number, but you don't need to divide every fraction by the same number. So I'm going to divide this guy by 4 over here. What I was just trying to do is, the numbers I picked for 3 and 4 that I was dividing by, I was just trying to pick the biggest number that goes into both numbers, top and bottom of one fraction. And so if I divide that, I get 1 on top of this fraction. And if I divide here, 18 divided by 3, well, that gave me 6. Over here, 4 divided by 4 is 1. And 24 divided by 4 is 6. So these triangles are similar to one another because I have two sides that have the same ratio. They're in proportion to one another. And we have one pair of angles, so by side, angle, side similarity, these guys are congruent to each other. So we could write a similarity statement that says BDA is similar to triangle CDE. All right, and so that's really all we're trying to do, is we're just checking to make sure that these guys are proportional to one another. All right, and so then we got this last one, and it's asking us, explain why these guys are similar, and then find the side SR, the red side right here. All right, so let's look at this. They drew some, I see some arrows. Arrows don't mean congruence. Arrows mean parallel. And so I have these sides. I have PQ is parallel to ST. Well, we can go around and do a couple different things. We could either say these guys, vertical angles, are congruent to one another. That's an option. So we have one pair of angles. So our choices, remember, are angle similarity, side similarity, or side similarity. And when it doesn't say how to do it, you just kind of got to look at the information that's given and decide what's best for you. So looking at this guy, I know, looking at the markings that I just made, I know that these two angles are congruent. So side similarity isn't going to be my best choice on this one. And having that these sides are parallel to one another, and instead of going through and checking, like making sure that all the sides are proportional, I'm going to go with another pair of angles. I'm going to say angle T here is going to be congruent to angle P because we have a pair of parallel lines and the Z shape, which gives us alternate interior angles. So by angle, these two triangles are similar to one another. And there's other ways. This isn't the only way. You could have set up proportions and then side angle side. The problem with side angle side is that I don't know anything about RS over here. So these two sides and squeezing the vertical angles makes it a little bit tougher. Not saying it couldn't be done, but I don't think that was the intent of the question. So now that we have this, we're going to set up our sides in proportion to one another to help us find RS. And this is another thing that we can do, is we can find missing pieces when we know the triangles are similar to one another. So I got to kind of look at my drawing up here, and I'm looking at the side PR. So PR are the first and last letters, so that's going to match up with TR from my similarity statement. So PR is over TR, and the other side that I have in this top triangle is QR, which are the last two, so that's going to have to match up with SR. So QR will match up with SR. And so now if I set these in fractions of one another, we should be able to find the missing piece that we're looking for. So PR is 25, TR is 30, QR is 30, and SR is unknown. And so that's the piece we're looking for. So to undo something like this is where we do cross multiplication. This is a way of undoing this and solving it algebraically. So we're going to multiply x times 25, so we get 25x. And on the other side, we're going to multiply 30 by 30, which is on the other side. And by doing this cross multiplication, we end up getting rid of the fractions, which most people like when we do this. So we end up with 900 over here when we multiply 30 by 30. Now if I divide by 25 to solve for x, we end up with x equaling 36. And so SR is 36, and so that's how we're going to find the missing side. So this concludes our examples for today. We'll do a few more in class. I look forward to talking to you guys.